Hello, today I'm going to show you how you're going to solve intro to log and log graphs in chapter 9 section 1. To me, this chapter is extremely simple because all you really need to remember is a few steps to go back and forth from the following equations. So I chose a rather simple equation just to get the base of it down. First, I gave you a simple logarithmic equation like so. The logarithmic equation states log base 381 is equal to 4. I'm going to show you how to go from this equation to this exponential equation right here. So what you're going to do is this base 3 on this log is going to become the base for this exponent. So it's going to become log base 3 to the power of 4. It's like this because it's just this number always becomes the bigger number for this. It's always going to become that because these two numbers, whenever this number to the power of this, will always equal this number right here. Like so, if you do 3 to the power of 4 in your calculator, it will always equal 81. Which is how you do that. And to go the other way, you're just going to do the exact same thing but backwards. So you're going to go from 3 to the power of 4 equal 81, and you're just going to make this the base of the log, and this is going to be after the log right here, and all that's going to equal the exponent of the 3 right here. And what that shows you is this number right here. If you were to multiply this, this will equal this. And if you were to multiply this, this would equal this. And all of this equals each other. All you really need to know how to do is you just need to know where that goes in the right spots. And you can solve any equation that looks like this no matter how difficult it looks. It's always going to be the same way. So it's just going to go from 3 power of 4 equaling 81 to log base 3, 81 equals 4. That's all you're going to do. Now I'm going to show you how to do log graphs. Log graphs are very simple, a little bit more difficult than the following part, but what they're going to give you is they're going to give you an equation like so. So this is going to be an equation, and what you're going to need to do is you're going to get this number right here, and that's going to be your A. So let's say this is A. You're going to plug it into the equation right here. This 2 was A. You're going to get A to the power y equals x. So you're going to do 2 to the power y equals x. And then that's how you're going to solve for the points in which you're going to graph on your graph later. So let's do this now. So right now it's 2y equals x. And it's going to be a lot easier to go from your y coordinates to your x coordinates, because if you were to go from your x coordinates to your y, you would plug in for x and you would have to solve for y, and it gets really messy and you don't want to do that. So what you're going to do is you're going to randomly put points for y. So right now I chose 1, 0, -1, -2 because those are very simple ones. So if you plug in 1, 2 to the power of 1 equals 2, 2 to the power of 0 equals 1, to the power of -1, that does 1 over 2, which equals 1/2. To the power of -2, that goes 1 over the power of -4, which equals just 1/4. And then, this is how you're going to start finding your coordinates. These are not your coordinates, though. What your coordinates are going to be is this right here. That's going to increase your y coordinates by 2, and this is going to decrease your x coordinates by -6. And since it's in the parentheses, you do opposite. So right here you get all your x coordinates, and you subtract 6, so 2 minus 6 equals -4, 1 minus 6 equals -5, 1/2 minus 6, these get kind of difficult, so 1/2 minus 6 equals -11 over 2, 1/4 minus 6 equals -23 over 4. It's really simple if you just if you're really good with fractions, which it becomes simple after you keep doing it over and over. And then for y, you just add 2 to it, so 1 plus 2 equals 3, 0 plus 2 equals 2, negative 1 plus 2 equals 1, and negative 2 plus 2 equals 0. And after that, all you have to do is plug these into your graph. And so let's do this real quick. So negative 4, 3. There's negative 4, 3. Negative 5, 2. Negative 11 over 2, 1, so that's a little bit over 5. And negative 24, negative 23 over 4, which is almost 6, negative 6, almost negative 6. So that will be right here. Right here on this line. So then after that, it's because all logarithmic lines look somewhat like this. That's what all of them turn out like. Whether it's backwards or forwards, that's just how they all start. That's what their parent function is like. So what you're going to do is you're just going to connect them like so. And that's your basic function. That's your line. That's all you need to do. You just need to get the points. This is how you make sure that these are not your points. You change them by doing the opposite of what's in the parentheses and doing what's on the outside to your x and to your y. And with this, you can do anything that you need to do, such as the domain, the range, and if you need to, you can find the equations of your asymptotes, which is, if you need to find your x asymptote, this is y equals 4, and y asymptote, which equals y equals negative 6. And with that, you can solve for anything, which, like I said, you can get domain, range, and you can find any transformations that you need with the parent function that starts at this right here. That's your original parent function. And that's basically it for 9-1. That's all you really need to know. Just it's all memorization. So that's it for any of my following videos. They will be posted behind it, and that's going to be it for 9-1. Thanks.